Global spending on artificial intelligence systems is forecast to reach $57.6 billion in 2021. AI industries could be worth $15 trillion by 2030. Realizing the value of AI requires access to large amounts of data. Spending on artificial intelligence in healthcare is worth $7.2 billion. However, the clinical data required by algorithm developers is the subject of strict regulations. Let's meet Alice, the Chief Data Officer of a large medical center. The medical center generates regulated data from its patients. The protected healthcare information is stored in a growing data lake. Alice understands that all this patient data could be used for medical research and to generate revenue for the medical center. Alice protects all of the patient data at rest to comply with her legal obligations regarding data privacy. However, she recognizes that this data becomes vulnerable when in use, as it must be decrypted at runtime. Now let's meet Bob. He is the chief data scientist at a company developing AI algorithms for clinical use. Bob has created a new algorithm that he thinks will provide improved patient outcomes for people with a chronic medical condition. The new AI algorithm contains the intellectual property of Bob's company and represents its principal source of future revenue. Bob protects the algorithm code at rest, but needs to train his model on the clinical data that is managed by Alice. Whereas Alice is concerned about access to her data, Bob doesn't want the intellectual property in his code to be lost when it is in use at runtime. Alice is concerned about the risk to her data, and Bob's concern about the risk to his code act as a barrier to collaboration and innovation. This barrier prevents patients from benefiting from new medical advances and prevents realization of the economic value in Bob's model and Alice's data. Fortanix removes the barrier to AI innovation through the power of a new technology called confidential computing. By placing Alice's data and Bob's algorithm within a secure, trusted execution environment, the model can process the confidential data without either party having access to the other's secret information. The computational workload is secured from potential attackers, and Alice can demonstrate compliance with her legal obligations over the sensitive patient data, enabling monetization of her data lake. Bob can validate his AI algorithm while protecting his intellectual property, accelerating his company's progress towards regulatory approval and commercial revenue. Fortanix Confidential Computing Manager enables multi-party computation and privacy-preserving analytics for data owners and application developers across multi-cloud and on-premises infrastructure.